So I told you guys yesterday you're going to have a quiz tomorrow on 7.1 and 7.2, so it's not going to include what we're doing today. And I thought we'd already talked about this before because I mentioned it yesterday, but we did not talk about it before. But I kind of showed you what the point slope form was, did an example using that yesterday. It's another way you can write the excuse me, equation of a line. And just like the title says, Keen, back where you belong. Move your desk. You can use this if you have the slope of a line and a point on the line. Okay, so we're going to learn about what the point slope is. We'll convert equations among the various forms. We'll write the equation of a line from 2 points on a line, and then we'll also look at solving a few problems involving the slope point form of a line. So, yesterday I showed you what the slope point form was. The point slope form or slope point form is y minus y1 equals m bracket x minus x1. It actually comes from the slope formula. Okay, so the slope formula that we've used before is that m the slope equals y2 minus y1 over x2 minus x1. So we've used that before. If you've got 2 points, you can use this to find the slope of a line. And we can use this to get the point slope. So the point slope is used if you just have the slope and 1 point. So instead of having x1 and y1, x2 and y2, we'll use y minus y1 over x minus x1. You see, most equations have an x and a y in them. That's what we're going to use the y and the x part for, because most equations have an x and a y in them. The point slope form is used if you have the slope, which is what m is, and a single point, which is x1 and y1. If you make the left side a fraction by putting the m over 1 and then cross multiply, you'll have 1 times y minus y1, which is y minus y1 equals m times x minus x1. That's where the point slope form comes from. That's above there. That's where it comes from. It is used if you have 1 point on a line and the slope of the line. It's an easier way to write the equation of that line, as long as you have 1 point and the slope. Now, as we go through these, I'll refresh your memory because we also did questions where we had a point and the slope using slope-intercept form, y equals mx plus b. So we'll look at both methods, and then we'll see which one might be a little easier to do. Okay? So, again, linking the ideas, just explaining where the equation comes from, which I've already done. Okay? I showed you where it comes from. So now looking at this example, use the slope point form to write an equation of the line that goes through negative 2, 5 with a slope of negative 3. And then we can also graph it as well. So let's start by graphing it first, because we've done that before. We start with the point, negative 2, 5. That point right there. And m, our slope, is negative 3. And we can write that as negative 3 over positive 1 or positive 3 over negative 1. We've seen this before. It doesn't matter. If I use the first expression for m, a rise of negative 3 means you go down 3, and a run of positive 1 goes to the right 1. And we can do that multiple times. Go down 3 to the right 1. Go down 3 to the right 1. Go down 3 and to the right 1. And we have room to do it one more time. Go down 3 and to the right 1. Or we can rise 3 and run negative 1. If we rise 3, that means you go up 3. Running negative 1 means go to the left 1. That works as well. That point lines up with all the other ones. I could do it one more time by estimating where the rise of 3 would take me and then run negative 1. And again, all these points will line up. So there is our line. Okay, and we always put arrows on the ends of our lines because, again, they go on forever in both directions. And now we want to write the equation of the line. And because we're given a point and the slope, we can use the point slope form, which again is y minus y1 equals m bracket x minus x1. Right, for your quiz tomorrow, which this will not be on there, but you'll be given the general form and the slope-intercept form. That'll be given to you. And you'll also get that when it comes time for any other quizzes and the exam. You'll get like a formula sheet that has all the formulas that you need. Okay, so now the point is -2, 5. That's the point that we started with. The line goes through that point, and m, the slope, is -3. So the -2, 5, that's our values of x1 and y1. And m, our slope, is -3. So we can put these values into the equation. y1 is +5, m is -3, bracket x minus x1, which is -2. So if we plug in those values, that's what we have. Okay? And so now it's just a matter of simplifying that. You'll have y minus 5 equals, the minus minus becomes a plus positive, so it'll be -3 times x, and -3 times +2 is -6. So again, this is the equation in point slope form. That is the equation in point slope form. Part B asks us to write it in slope-intercept form. So we would continue working with this equation by adding 5 to both sides, because remember, slope-intercept form is y equals mx plus b. You've got to have positive y by itself on one side. On the other side, we'll normally have two terms, a term that has the x, a term that doesn't. The term that has the x tells us the slope. The number in front of x is m, tells us the slope, which is -3. And the term that doesn't have the x, the constant term, that's b, our y-intercept. So this line has a slope of -3, which we drew the graph with the slope of -3. It also tells us that our y-intercept should be -1, which is correct. Right? So now this is in slope-intercept form. Okay? So those are two different forms of the line. Now, we also did questions like this prior, back in 7.1, by using slope-intercept form. So this would be an alternate way to get this same equation. All right? So what we did is we plugged our slope in first. Our slope is -3. So y will equal -3 times x plus b. And then what we did is we figured out what b was by using the point. If a line goes through the point -2, 5, that point must satisfy the equation. When x is -2, y must equal 5. So that's what I'm going to do. I'm going to let x equal -2 and y equal +5. So if I sub those in, we only have one variable left, and that is our b variable. So we can solve for b. So on the right side, negative 3 times negative 2 is positive 6 plus b. And then to get b by itself, you would subtract 6 from both sides. 5 take away 6 is negative 1. Our b value is negative 1, which matches what we got over here. And our slope is negative 3, so in slope-intercept form, we would say negative 3x minus 1. Same equation that we got over here. We just did it a different way. And this different way, the second way that we did this back in 7.1. We saw examples where we had a slope and a point, and we could still write the equation. So now this gives us another way to do that. Point-slope form. Either way, you get the same answer, right? So it doesn't really matter which way you do it. All right? So on the next page, graph the line passing through the point 2, negative 3 with a slope of positive 1/2. So we start with the point 2, negative 3. And a slope of positive 1/2 means you rise 1 and run 2. Rise 1 and run 2. Rise 1 and run 2. You can also do it by making them both negative. A negative divided by a negative gives us a positive. It'll also work if you rise negative 1 and run negative 2. Go down 1 and to the left 2. Down 1 and to the left 2. It doesn't matter how many times you do this, the points should all line up. And we can draw a line going through all of these points. And now we want to write the equation using the point-slope form, which remember is y minus y1 equals m bracket x minus x1. Our point is 2, negative 3. And the slope m is positive 1/2. The point 2, negative 3 is where our values of x1 and y1 come from. And m is our slope. So it'll be y minus negative 3 equaling m, which is a 1/2 bracket x minus 2. Minus minus becomes a plus positive. So this is our equation in point-slope form. Question 3 asks us to write it in slope-intercept form. So that's y equals mx plus b. We need to get positive y on one side. On the other side, we should have only two terms. One that has an x, one that doesn't. So I'm going to multiply out the brackets on the right. 1/2 times x is a 1/2 x. 1/2 times negative 2 is minus 1. And then if you subtract 3 from both sides, negative 1 take away 3 is minus 4. So our line should have a slope of 1/2, which we drew our line with a slope of 1/2. But also, b, the constant on the right, is negative 4. That should be our y-intercept, and it is. When we drew it, the graph went through the y-axis at negative 4. So it is the correct y-intercept. So again, this is slope-intercept form. Okay, that is the slope-intercept form. So we'll do the same thing for this next one. Our point is 3 comma negative 4. M, our slope, is 2, which could be 2 over 1 or negative 2 over negative 1. When you divide negative 2 by negative 1, you still get positive 2. We'll start with the point 3, negative 4. And then we can rise 2 and run 1, rise 2 and run 1. We can continue that for as long as we have room for it. Or we can rise negative 2, which means you go down 2, run negative 1, which means go to the left 1. You can also do that a few more times until we run out of room. So there's all the points that our line will go through. And again, we draw arrows on the ends of our lines because the graph continues on forever in both directions. So there is the line. Now it says this gets express the equation in slope-intercept form. But first, I guess part A says use slope-point form to write the equation. Right? So that's what we'll start with. Point slope is y minus y1 equals m bracket x minus x1. x1 and y1 come from the point. x1 is 3, y1 negative 4, and m, our slope, is 2. So y minus y1, which is negative 4, equals m, which is 2 bracket x minus x1. Minus minus becomes a plus positive. There's our equation in point slope form. We use the point and the slope to get it. And now part B asks us to use or write it in slope-intercept form. So that'll be done by multiplying out the brackets on the right and then getting y by itself by subtracting 4 from both sides. Negative 3 take away 4 is minus 7. So our line should have a slope of 2, which it does. We drew it with a slope of 2, but also the y-intercept should be negative 7. 1, 2, 3, 4, 5, 6, 7. So there's something wrong there because I didn't multiply this 3 by 2. So that was my mistake. 2 times minus 3 is minus 6, and then when you subtract 4, you'll get minus 10, which is the right y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So having that graph is a good check. Without the graph, we might not have known that we made a mistake. And I said we because it was Keen's fault. Huh? All right. So you see how useful this point slope form is. Example 2, though, doesn't give us the slope. It gives us 2 points, but it still wants us to use slope point form to write the equation. To do that, we need to have the slope and a point. We don't have the slope. We have 2 points, but we can use the original slope formula to find out what the slope is. And this will be given to you for your quiz tomorrow. Don't have to memorize it. Right? So our points are 3, negative 4, and 5, negative 1. One of the points is 0.1. That gives me x1 and y1. The other is 0.2. That gives me x2 and y2. That's what gets plugged into here to get your slope. y2 is negative 1. Take away y1, which is negative 4. Over x2, which is 5, minus x1, which is 3. The minus minus becomes a plus positive. Negative 1 plus 4 is positive 3 over 5 minus 3 is 2. The slope of the line is positive 3 halves. And so now, to use point slope, we'll use a slope of 3 halves, and we can use either points. And I'll show you, it won't matter which one we use, we're going to get the same equation at the very end when we write it in general form. So if I use the 0.3 negative 4, y minus y1 equals m bracket x minus x1. It'll be y minus negative 4 equals 3 over 2 bracket x minus 3. Minus minus becomes a plus positive. It'll be y plus 4 equals 3 halves x minus. So you multiply 3 halves by x, or x over 1. That's where the 3 halves x comes from. Then you also multiply 3 over 2 times negative 3 over 1. Because you multiply fractions by going top times top, bottom times bottom. So 3 times negative 3 is our negative 9 over 2 times 1. Okay, and now we are going to write it in general form, which is what it asks us to do. We would do that by multiplying all the terms by 2, because that's your common denominator. So the y will get multiplied by 2, the 4 by 2, the 3 halves by 2, and the 9 by 2. That'll give us 2y plus 8 equals, here the 2's cancel, you're left with 3x minus, here the 2's cancel, you're left with 9. So 3x minus 2y, remember that general form, everything on one side equal to 0 on the other, and we want the x term to be positive. So I'm taking everything from the left, moving it to the right. When you have an 8 here and you subtract it from both sides, negative 9 take away 8 is minus 17 equals 0. So this is our equation in point-slope form. This is our equation in general form. So that was using the 0.3 negative 4. But what if we use the other point, the 0.5 negative 1? It doesn't change the slope, but now x1 and y1 are different numbers. So what does that look like? So again, there's point-slope form. y1 is negative 1. Our m isn't going to change. x1 is positive 5. So y minus negative 1 becomes y plus 1, equaling 3 halves bracket x minus 5. So that's the point-slope form. And that is different than the point-slope form that we have over here. Completely different. The only thing that's the same is our m is 3 halves. But let's see what happens when we write it in general form. So 3 over 2 times x, and then 3 over 2 times minus 5 over 1 will be minus 15 over 2. 3 times negative 5 is where the 15 comes from, over 2 times 1. When you multiply everything by 2 here, to get rid of the denominators, you're going to have 2y plus 2 equals, here the 2's cancel, and you'll have 3x. Here the 2's cancel, and you'll have minus 15. So when you bring the two terms from the left over to the right, the 3x stays positive, the 2y will become minus 2y, and when you subtract this 2 from both sides, negative 15 take away 2 is minus 17. You get the same equation in general form, which shows us that it doesn't matter which of the 2 points you use. If you do everything correctly, you'll get the same equation in general form at the end. You'll get the same equation in general form at the end. Okay? And we could graph it by using the 2 points. 3, -4. 3, -4 is down there. And the other point is 5, -1. That's right there. So there's our line going through these 2 points. Okay? So there's our line going through those 2 points. So on the next page, we want to graph a line going through those 2 points, the point 3, 1 and 0, 0. Now in the last example, we used the slope formula to find the slope. But you don't have to do that, because once you have the graph, you should be able to count to get the slope. So if we go from the point 0, 0 and we go to the point 3, 1, we would rise 1 and run 3. Remember, slope is rise over run. You're going to rise 1 and run 3. So the slope, which is rise over run, will be 1 over 3. So this saves you doing the slope formula if you draw the graph. And we could have done the same thing on the previous one. If we look back, we can count the rise and the run. That'd be a rise of 3, a run of 2. So there's our slope 3/2, instead of using the slope formula. Okay, so it says identify the x-intercept. Well, the x-intercept and y-intercept are the same here. Because the graph goes through the origin, it crosses both the x and y axes at 0. Our slope, we just figured it out to be 1 over 3 by doing the rise and the run. So now we want to write the equation in both point slope form and slope intercept forms. And as we've seen, we can use either point to do that. It's going to be easier to use the point 0, 0 than it would be to use the point 3, 1. They both will work, but I'm going to use 0, 0 because x1 and y1 are both 0. Y minus 0 is y, and that will equal 1/3 times x, and then 1/3 times 0 is 0. So there's the equation. This is the equation in point slope. This is the equation in slope intercept. The fact that there is no b value, that the right side is just 1/3 x, there is no value added or subtracted on there, means that b is 0. The y-intercept is 0, which is consistent with our graph. Okay? Consistent with our graph. So this one we can do exactly the same way. We might as well start by graphing the line, goes through the point -5, 2 and -2, 1. this line will have a negative slope. As you go left to right, the line is falling. It's going downwards, which means that the slope is negative. And we can figure out what the slope is by counting our rise and our run. So from the first point, you would rise -1 and run +3. You would rise -1 and run +3. So that's our slope, -1/3. And it doesn't matter which point we use. I'm going to use the point -2, 1, just because the numbers are a little bit smaller. Point slope is y minus y1 equals m bracket x minus x1. y1 is 1. M, our slope, is -1/3. x1 is -2, so you're going to have x minus -2. And once again, the minus minus becomes a plus positive. So there's our equation in point slope form. Then we're asked to write it in general form. Okay. Now, if we start with this equation, you actually don't have to multiply out the brackets if you don't want to. You can go directly to multiplying everything by 3. And because the right side is in factored form, you've got one thing multiplied by another. You don't have separate terms, but you have two factors. You just multiply that entire right side by the common denominator of 3, and those 3's cancel. Because it's not separate terms like on the left, you have a term of y and a term of -1. Two different terms. The right side is in factored form. You've got two factors. Not two separate terms, but two factors. Factors are things that are multiplied together. So because of that, you can just multiply everything by 3, and you only have to do it to one thing on the right, because it's all part of the same factor. So this gives us 3y, take away 3, equals -1 times x, and -1 times 2 gives us that. And you remember general form, the x has to be positive. So we're going to move everything from the right side over to the left. The x will become positive, the 3y stays positive, and then when you add 2 to both sides, -3 plus 2 leaves you with -1. And so there's the equation in general form. Okay? And I could have used the point -5, 2 instead. The point slope form would look different, but the general form would look the same. It would be the same. Okay? So this is your assignment. There's questions on both sides for you to do. And because Keen's going to ask if this is due, we'll make it due. Because he was going to ask. So this one you're going to hand in. There's two sides. One page, two sides. Okay? So tomorrow, we're going to spend one more day looking at point slope. You guys will also write your quiz on 7.1, 7.2. This stuff we learned today will not be on the quiz. Right? And then we're going to finish off 7.4, and then it'll be your next unit exam.